Brian Gold. I'm with Pure Storage. I was part of the founding teams, one of the early architects of our FlashBlade product line. And it's been a real delight to work on this technology over the last, for me, this is coming up on 8 years that I've been with Pure. And we've been in production now for 5 years with FlashBlade. And it's been an awesome experience. And so today in this session, I'm going to tell you a little bit about our technology, what we built, how it works. But more importantly, we're going to talk about some of the lessons learned over the last 5 years, and in particular, what we've been doing with customers, and take some live looks at the product in action. So with that, let's get right into what is it. So in case you haven't seen FlashBlade before, we call it Unified Fast File and Object Storage. And it's a bit of a mouthful. So what do we mean by all of that? Well, we're talking about a scale-out architecture that's built really for the needs of modern unstructured data. And as the name implies, it's a blade-based modular architecture. We've got a couple of different blade sizes, so there's a hardware form factor here. We've specialized this knowing, like all products at Pure, that we're going to build this around an all-flash substrate. And so we've got a couple of different blade sizes, and we scale from what today is small sizes at 7-blade systems that are about 60 terabytes of usable capacity, all the way up to 150 blades in a single system. We've focused, as you would expect, on some of the high-end performance needs of modern data, but we've delivered a lot of really rich enterprise features. And so we occupy with this product of what we think is a very interesting spot in the design space that is performance-oriented scale-out storage that meets the needs of a lot of enterprise users with rich data services. We've put a lot of work into a high degree of simplicity in the product, and that shows through, and that's what I'm going to try to help get across with some demos and further detailed technical deep dives today. So with that, a little bit of orientation into what the product looks like, and just to set some context, I want to take a step back now and try to get to, well, the why. Why did we build this product? Why did we build it the way we built it? And to understand that, it's a little bit useful perhaps to go back in time, right? Where did unstructured data start? Where did, and for a lot of us, for me personally, this started in the 90s with, some file sharing. The first time I remember getting onto a LAN, and certainly things existed well before that. But there were, there were really good uses for unstructured data and sharing of data. That's really one of the key attributes that we look at in this space is you connect multiple computers over a network and have shared access to common data. And so these were shared file protocols, content repositories, and the emergence of object storage has certainly been around a while. But those same mechanisms, I think what's in many ways so fascinating about this space is that those same basic mechanisms have held true for 30, 40 years at this point, but the actual applications have evolved radically. And so if you look at, it's kind of almost every buzzword in the modern data space, it's very real today. And we have customers in all over the sort of different verticals, different industries that are, the common theme for a lot of them is they're using machines to generate data and machines to analyze that data. And the capacity, the ability to generate and analyze that data has scaled with Moore's law over the years, and it has scaled now into, data centers and warehouse level computing systems that, while we may still speak file and object protocols under the covers, the actual demands are at orders and orders of magnitude larger than when we started. And so, we think of this, and really the problem we set out to solve was that the needs of modern applications, they really need scalability, they need a lot of performance in different dimensions, and we also need really rich data services to be able to manage all this data, especially in an enterprise context. And so when we started working on, the product that is now FlashBlade, we took a look around and said, okay, well, what's happening in the industry today? And we saw a high degree of fragmentation. And this is really the problem with a lot of the existing approaches that have evolved. These are some great products. They've been in the industry for a long time, but there's a lot of silos that were built that are holding back, sort of the agility of a lot of these modern applications, whether they're, systems purpose-built to be kind of a general purpose filer or a scale out system for media and entertainment, or a Hadoop file system somewhere, a purpose-built backup appliance somewhere. There are a lot of very customized siloed architectures that increased complexity for IT teams. They can't necessarily meet all the different dimensions of performance that modern applications need. Or if they can deliver the performance, they sacrifice a lot of the enterprise data services that are still very relevant and very needed, even in the use of, even for modern applications. And so what we set out to build was a system that would deliver on a lot of different requirements that we saw in modern data. The need for really multi-dimensional performance, having a self-healing, simple, easy to scale architecture, something that could interoperate with workloads that were moving increasingly to kind of hybrid cloud architectures, and as well as be able to scale to really large sizes with ease and support a lot of the different protocols and feature sets that are needed, so that we can meet applications where they are and support customers on their journey to scale their business and their applications. So we're 5 years in to production with this product. How's it going? And we're really, really delighted. I mean, we couldn't be happier with how things have gone for us in the market. All new products, you can build great technology. There's an incredible challenge in identifying that product market fit. And we are just delighted with how customers have received the product. So I'm not going to spend a lot of time on sort of the business results, but we've recently posted a blog that talks about we're nearing $1 billion in total all-time sales of the product. We've added several hundred new customers. We're growing the size of individual customers quite a bit. And we've been on a great run of quarter after quarter of growth in the business. So we're really, really happy with the reception in the market. And that's certainly one way to measure the success of new technology. But to me, as an architect, I am perhaps more thrilled by the diversity of industries and use cases in our customer base. And the fact that we've built a platform that can support customers across all different sizes of organizations and all different industries. And I'll spend some time in following sessions diving into a few of these in depth to show you really how they're using the product. And so we're very, very happy to be able to support so many customers with such a diversity of modern data use cases. And across the board, and this is something that if you haven't seen Pure much before, this is a standard part of everything we do across the company, is driving satisfaction for our customers. And we measure this regularly as part of a net promoter score. And I can tell you, as somebody from the engineering and product organizations inside of Pure, we take this really seriously. We look at it every single week in our regular staff reviews. What's happening? How are we doing? What can we do better? Because everything can look for some degree of improvement. So we've been very, very happy to see this validated externally. And certainly FlashBlade has been a core part of that. This represents the 83.5 net promoter score. This represents all of Pure, and we're a big part of that in the FlashBlade organization. So that's enough of sort of the business pieces. What I'm really here today to talk with you about is what were the big ideas in FlashBlade? And how have they played out for us? So we're going to spend a bit more time talking about the architecture, the tech, and how customers are leveraging that. And I want to do that by talking about three really big ideas and three architectural bets that we made in this product. We'll start at the really foundation layer. We wanted to solve the needs of this scale out platforms by simplifying what it means to create scale in a hardware software integrated system. And so I'll spend a bit of time digging into what we've done at that platform layer. And on top of that, we layer a rich set of core data services. These are still internal to our platform and how we build the system. And really, this is about how we deliver performance. The performance, yes, we get performance from Flash. That's an enabler, but it's so much more than that. We've built a distributed database, and I'll talk in a little bit of depth about how we did that, how we architected it, and what it's done for customers. And then we'll finish up with really what all the foundation layers enable, which is protocols, data services, capabilities that end customers interact with, and the feature sets and capabilities that they get from us. So these are the three themes we'll do in some follow-on depth. This is an enormous undertaking for us. and is for any organization wanting to build a product of this scale. There's so many features and mechanisms, and I can show you hundreds of slides of all the icons and the logos. But really, I'd much rather actually let the product speak for itself. And so we'll do a bit of a live demo here. And what I want to do is actually show you some production systems that we use internally. And so like a lot of large scale systems, it's really important that we as they say, eat our own dog food. But keep in mind, as I walk through this, we're a couple hundred software engineers working on this product. And so we are representative of exactly a target customer segment for us. We practice, agile software development. We have a strong DevOps methodology. We do continuous integration. People are building, new feature sets every day that they submit for testing. And so what I'm going to show you here on the product itself is the backend storage systems that power a lot of that infrastructure, because it takes a lot of infrastructure to support a couple hundred software engineers working globally on a product like this. So let me flip over to a live look at the base entry spot of a FlashBlade GUI. So what you see here, let me just to orient you on the screen. Maybe 1 second. To orient you on our main GUI here. At the top, you have the base capacity orientation. You see this system has 400 terabytes of capacity and use for file systems. We've got some snapshots. We have a little bit of object storage data loaded on here. This is mainly a file backend workload on this particular system. And we have some real-time performance overview charts. You can see this is a steady state. There's a lot of activity. So at the application layer, what's happening on this particular system is we have a couple thousand virtual machines that are accessing this as part of our continuous integration pipeline, what developers use all the time. And so that's what's driving a lot of the activity here. I'll take you through a little bit of some of the other data services that we're offering up on this system. But you can see over on the right, a basic visual of the hardware health, some icons, everything's happy. There are 15 blades in this system. Each one is 52 terabytes raw capacity. And in aggregate, it kind of pulls the system together in this simple overview chart. Of course, we can dive much, much deeper. And so just to give you a sense of how, and I've zoomed in on the fonts a bit here to try to make them more visible on the stream. But we have a set of different file systems. These are easy to provision either through the UI or via REST API or a CLI, all the same mechanisms under the covers. And so you can see we're running some pretty standard developer infrastructure. We've got a JFrog Artifactory instance that serves up build artifacts. We've got a Prometheus database backend that serves up metrics for us to monitor all these thousands of VMs and various other infrastructure. We've got a Jenkins instance, on and on. This is pretty typical of what we see in a production customer environment where they're doing high-scale software development. Some of the tools might change. We have customers with petabyte scale Perforce instances, and we're more of a Git shop, but we have sort of a pretty, these days, standard looking environment here for supporting a lot of the data requirements of modern software development. So this is one of our systems. I will flip over to another window here. This is a little larger system. So this is another FlashBlade in our internal dog food environment, as we say. And so you can see same basic visual. This one has nearly 2 petabytes of space in use. That's nearly 2 petabytes after the data reduction. So you can see we're getting 3.8 to 1 through our compression schemes inside of FlashBlade. And this is a 75 blade system. So you can see the little icons here. And when we flip back to some pictures, I'll show you some photos of what that looks like in practice, in reality. But this is a simple visual. You can see the performance that's happening. What's happening here live in the system is a little different from the other view that I showed. In this system, we're driving pretty high, read and write bandwidth, close to a gigabyte a second. But notice the IO size is actually pretty small. Like this is, we'll have periods here where these are 32K. This workload is fairly random IO through this environment. And so what's happening? Well, the applications driving this particular system are part of our continuous integration system. And so what we found a few years ago, as we scaled the number of developers, the amount of infrastructure just to do our internal automated regression testing, was we were actually kind of starting to drown in log data. So every single VM, every single application, every single instance of whether it's a simulated FlashBlade that we use for kind of unit tests or a full-scale hardware system that's in our automated testing environment, every single piece of that infrastructure generates a lot of log data. And this is the tip of the latest developer check-ins. There may be bugs that we're trying to identify through all this testing. And if they have to sift through massive amounts of log data, that's a real problem. And so we built an entire streaming analytics pipeline to try to identify those problems before they get too long and to improve developer productivity. And it turns out that's what a lot of our customers are doing. They're building streaming systems. Now, maybe they're not all doing software development. Maybe it's a click stream from a SaaS portal, or it's large-scale financial trading data or IoT sensor data. But the needs of real-time streaming sensor data are pretty massive. And you can see there's a varied workload. Like live on this system right now, we have a spike of metadata operations. As people run different jobs, we can come in and do analysis on the data that's sitting in this repository. So all these logs that are coming in, if we flip over to the performance view, we can analyze historical data. You can see there's some variation as different jobs run on this system. We can look at and we can drill into different file systems. So one of the challenges that we try to solve for customers is when you consolidate a lot of different applications in a data pipeline like this, from an infrastructure level, we have to provide visibility into different parts of that, what's happening, and all this consolidation that we can do. We've got to be able to give tools to customers to be able to diagnose potential issues, even when those issues may be at the software level in their application, right? The infrastructure is working fine. It's an application issue. And so you can see we're running a Kafka cluster where all of the data that's in the, stored in the Kafka brokers is actually backed by a FlashBlade here. We've got the large producer of data here is a log collector system we call WatchLog that we built. That's what's driving most of the data collection here. But there are a variety of different tools and part of this pipeline that, I show this to you as an example of exactly what our many of our customers are doing with this platform. It's one system. All of this data can be served to hundreds, thousands of connected servers in an environment, and they can mount all of this and get all of the performance and capacity and scale with one IP address if they want, or multiple if they want to segment their network. A high degree of simplicity in what it takes to deploy this. And so hopefully this gives you a bit of a view into what the actual system looks like as I walk through kind of architectural diagrams and more visuals that highlight how we built it and what's inside of this system. But hopefully this orients you a bit to what's going on in an actual product.
Quick question for you, Brian.
Please.
How granular can you go on kind of the performance monitoring? Can you go down to kind of like object or file level performance details? What's kind of the granularity of it?
It's a great question. And this is something we've been working on incrementally with customers, driven by customer demand for the last couple of years as we got into more and more high scale environments. And so today we can segment at the file system or bucket level, which is kind of, you're seeing that view here. We have the overall array level view. We can also segment by the connected client. So we can tell which IP is showing issues. We haven't gone to the level of individual files just yet, although that's something we're definitely looking at. There's so much you can try to segment this. And so we tend to try to work directly with customers to understand, in their environment, what do they need to be able to diagnose, potential issues. Our general recommendation, and we have a number of integrations that we've done, but our recommendation is to actually use the REST API for customers that are really looking for granular details. And we have some more advanced granular telemetry that can be collected, like which client IPs. That's best done over an API, and we enable that. And we have integrations with Prometheus, and we have customers that build, nice dashboards in Grafana that pull together all of the metrics from our part of the world, plus all the other, thousands of things in their environment to make sense of it. This has been, and I think you all have probably seen, this has been a big push for observability in the industry. It's directly related to the kind of applications we're working with. And so this has been a big investment we've been making and we'll continue to make in our product.
Great. Thanks, Brian.